Hello everyone. In today's session, let us see few problems based on the power patterns. In the previous session, we have seen basically why array system is being used. You can see it on the screen. Why array system is used. What are the different parameters on which your pattern of an array system depends on? Okay, there are some 5 to 6. I have listed it out. And then we have seen what is a point source. It's an hypothetical antenna with 100% efficiency which radiates perfectly in all directions. Okay, it's a hypothetical theoretical antenna. Then what are power patterns? Basically in radiation patterns, the patterns are the three-dimensional graphs which show certain parameter variation, okay, for an antenna. In case of patterns, there are two types. Either it can be power pattern or intensity, radiation or field patterns. In power patterns, we take the variation is with respect to the radial component of the pointing vector. You can see it here. This is the spherical coordinate system. We have assumed this as the point source. This is the radial component of the pointing vector SR. So the variation is with respect to SR. However, the remaining two coordinates of a spherical coordinates, what are the three coordinates? The three coordinates are r, theta and phi for a spherical coordinate system, out of which we will consider only SR. S theta and S phi, we will keep it 0 for power patterns. Okay, you can see it here. For any isotropic antenna, the power pattern, three-dimensional power pattern, it will be sphere because it will cover the complete omnidirectional. Okay, all directions it will radiate uniformly. So it is a perfect sphere. So it is angle is 4 pi. Now power theorem, we have seen it already. What is P? It is the surface integral of a radial component of the pointing vector with respect to certain area, surface integral. We have seen this. Today, let us see some problems based on the power patterns. We have to follow certain some 2 to 3 steps in order to find the directivity of an antenna using the power pattern. So whenever a pattern is given to you, say this is one pattern given to you, we have to find what is the directivity. What is the directivity? The directivity is what? What is the maximum radiation intensity of an antenna in a particular direction? So that we need to find out. For that, we need to follow certain steps. Very first step is using this equation, the total radiated power W, which is the surface integral, double integration of radiation intensity into d omega. It is the solid angle. So through this, U will be given to you, that is the power pattern will be given to you in terms of radiation intensity. Hence, you have to go for the first step, calculate the total radiated power W. After that, the second step is for an isotropic antenna. You know that isotropic antenna is a hypothetical antenna which radiates uniformly in all directions. So if you consider in all directions, this is a two-dimensional. If you take the three-dimensional system, the power pattern for isotropic antenna is what? A sphere. So the angle is, it is covering 4 pi radians. Hence, the total radiated power is 4 pi into U naught. This is your second step. Once you take these two steps, finally the third step is the directivity D is given by the maximum radiation intensity of an antenna divided by radiation intensity of an isotropic antenna. See, whenever we try to check the performance or the efficiency of any system, we check it with respect to certain standard. For example, if you have achieved 500 marks and your total marks are 600, so how will you evaluate your performance? Your percentage, it is your obtained marks divided by the maximum marks. So the standard set by you is 600. So how much efficient you are, you will calculate. In the same way, the directivity is the maximum radiation intensity of an antenna divided by with respect to certain standard, that is isotropic antenna radiation of that. So it is um by u naught. Using this equation, we can find the directivity. These are the 3 steps to be followed. As a note, you can see it here. Uh, if a power pattern given is unidirectional, assume it is unidirectional, then the range of theta is between 0 to pi by 2. Okay, only one quadrant. And the range of phi is 0 to 2 pi. It will take uh, two quadrants. I am talking in terms of this. Okay. So each quadrant is how much? 90 degrees, 90 degrees. Each one is 90 degrees, so that the total is 360. So if theta is, say, unidirectional, for unidirectional pattern, theta range is only this much. And phi range is this much, two quadrants. So 0 to pi by 2 and 0 to pi. And if the given pattern is, say, bidirectional, the theta range will be sorry, phi range is 2 pi, right? So 2 pi means it will cover all. It are not two quadrants, all four quadrants. 1, 2, 3, and 4. So theta range is what? Only this much, and phi range is complete. 360. 2 pi is 360. I'm sorry. Um, for bidirectional, theta range, check the theta range. What is the difference? It will cover now 180 degrees, two quadrants, and phi range remains the same. See, for both, phi range is 0 to 2 pi. For unidirectional, take the theta only 90 degrees. For bidirectional, take the theta 180 degrees. So this is the base. As a note, you should check it. Now we'll start solving the problems. First problem, find the directivity of the following power patterns. So first one is unidirectional cosine power pattern. This is the question. So cosine means what? The equation will be cos theta. Okay. And any cos or sine angle we represent generally, say x of t, or any, you might have taken this in terms of in signals and system also. It is a cos omega t. So amplitude and the angle, you will mention both. So likewise, if I want to represent this cosine power pattern in terms of equation, then I will write u is equal to maximum value amplitude um cos theta. Why only u? Because if we have seen here, we have seen it, first step is we need to find the total radiated power. It is in terms of u, radiation intensity. So what I will do, given cosine pattern, I will write like this: u equals to cos theta. This is the amplitude, this is the angle. Okay. Now one more data is given to you. It is unidirectional. So range of theta and phi you should first list out. Unidirectional, only 90 degrees, 0 to pi by 2, and phi is anyhow it is 0 to 2 pi. Once you do this 0 to 2 pi and 0 to pi by 2, let's start following the three steps. First step is, we need to find the total power radiated by an antenna, that is W equals to double integration of U into d omega. And according to the given question, this first outermost integration is for phi, innermost integration is for theta. What is the theta range? Unidirectional, it is 0 to pi by 2, and phi is 0 to 2 pi. And what is u? U is given cos theta. Okay, this I have substituted in term instead of u. And what is d omega? We have seen this d omega equation in spherical coordinate system. It is sine theta d phi. Instead of d omega, substitute sine theta d phi. The explanation you can go through when I was dealing with module 1, the antenna parameters, beam area. I have explained you why d omega is sine theta d theta. Okay, and d phi. D phi is for this first integration, the outermost integration. This is the variable. For inner integration, it is sine theta into d theta. Okay. Now the next remaining is you need to solve this. As there are two variables, one is theta, one is phi. So two integrations are there. I will just club the first integration. Um is a constant term. I will take it outside. First integration is for phi. This integration is for phi. I will club this d phi with associate with this first integration. And what all are remaining? This I have already done. See, I have already written. Okay. This integration term I have written. D phi I have associated with first integration. Then I will write the second integration 0 to pi by 2. What all are remaining? Cos theta, sin theta, d theta. So I will write cos theta, sin theta, d theta. So what I have done, all the 5 terms I have written at one integration. All theta variables, they are all clubbed together and I have kept it under second integration. Now apply the integration. Uh, First is as it is a constant. What is the integration of dx? Integration of dx is what? X. So integration of d phi will be phi. And what is the range? It is between 0 to 2 pi. Apply the limits. It will be 2 pi, upper limit is 2 pi minus lower limit is 0. So 2 pi minus 0 is 2 pi. I have written that 2 pi directly here. And then the second integration, as cos and sine terms are involved, what I can apply is I can solve this integration by substitution method. How to do that? I will do this substitution of, say, put sine theta is equal to x. If I substitute that, what is the differentiation of sine? It is cos. So cos theta into d theta will be equal to, see, theta is the variable, so I have to associate d theta. Cos theta into d theta is equal to dx. Okay. Uh, Integration limits for theta is 0 to pi by 2. But when I substitute theta in terms of x, limits will also change. So let's see, if theta is 0, the lower limit, if theta is 0, what is the sine 0? Sine 0 is 0, so x value will become 0. X is equal to 0. Okay, it's very clear. If you substitute here theta value as 0, sine 0 will become 0 and the sine 0 is equal to x. So x is equal to 0. And what is upper limit? It is pi by 2. So theta substitute pi by 2. If you substitute theta as pi by 2, what is sine pi by 2? Sine pi by 2 is 1. This value is equal to 1. What is this 1? 1 is equal to x. So x is equal to 1. Range for theta was 0 to pi by 2. For range for x is 0 to 1. So substitute the range. And what is sine theta? Sine theta I have substituted it as x. And cos theta d theta will be, see here, cos theta d theta is dx. So I have substituted dx. After that, so this just write this 2 pi as it is. Now what is integration of x? It is x square by 2 with the limits of 0 and 1. So now apply the limits. If I apply the upper limit, this as it is 2 pi apply the upper limit 1 by 2. 1 by 2 I have written, minus 0 by 2. So that will go. So only 1 by 2 will remain. 2 gets cancelled. You will be left with pi into This is first step. We have calculated the total radiated power W, which is equal to pi into Then let's go for the second step. Second step, for an isotropic antenna, it is a standard equation. It radiates uniformly in all directions. So W is 4 pi times U naught. U naught is the radiation intensity of an isotropic antenna. So 4 pi U naught is W. This is your equation 2, step 2. What is step 3? According to this, we have taken here, step 3 is we need to take the ratio of by U naught. If you check the equation 1 and equation 2, equation 1 has equation 2 has U naught. So we need to take the ratio of by U naught. That's why I will do this, taking the ratio of first equation by second equation. If I take that, see, LHS is W. So W by W is equal to pi divided by 4 pi U naught. So pi cancels, W cancels. 1 is equal to 1 by 4 by U naught. But what is by U naught? By U naught is actually directivity D. So it is 1 is equal to 1 by 4 into D. So what is D equals to? D is equals to 4. So we have calculated the directivity of the power pattern. What is that power pattern? It is unidirectional cosine power pattern. Directivity we have calculated as 4. And in the previous sessions, when I was discussing with the directivity part, I have already explained you directivity, for any hypothetical antenna, ideal antenna, it is 1. Isotropic antenna, it is 1. For any practical antennas, the values will be more than 1. Okay, so directivity can't be less than 1. Maximum, the ideal value of directivity is 1. And all other practical antennas which you come across, say loop antenna, helical antenna, you have many reflectors around you, Yagi Uda antenna, then there are many lens reflector, many paraboloid, many antennas are there. Or for any of these antennas, the directivity value is more than 1. Ideal value is 1. Let's take one more problem. Bidirectional cosine power pattern. So for bidirectional cosine power pattern, see, again, if you just observe the first and the second question. First question was unidirectional cosine. Second question is bidirectional cosine. So what is the difference? Given equation is same. Only the range of theta will change. Earlier it was 0 to pi by 2. In a bidirectional, it will be 0 to pi. 2 quadrants it will cover. So every solution, it will remain the same. What I have done, step 1, finding the total radiated power W, which is double integration of u d omega. U I have substituted um cos theta, d omega is sin theta d theta. For this integration, it will be d phi. And this, it is already covered here. So again, I have taken 2 separate variables for integration. One is d phi, one is d theta. For d theta, earlier how we solved? Earlier, the range was 0 to pi by 2. Directly we have taken substitute sin theta is equal to x. Steps will remain the same. What I will do, here the integration is 0 to pi. So I will make use of one integration property. The property says, if the range is say 0 to uh, 0 to pi x dx, some function is there, then it is equivalent to 2 times 0 to pi by 2, right? So 90 plus 90 is 180. So 2 times 0 to pi by 2 limit x into dx. So this property of integration I will use. So integration is 0 to pi. What I will make? 2 times 0 to pi by 2. I can write it like this, remaining all are same. And if you just go for substitution method, again just like the earlier check out what integration value you got. When you put all this, you will get integration like this, then x square by 2, then half. Integration value you get it as 1 by 2. So what I will do here, this 2 keeping as it is outside, this complete integration 0 to pi by 2, you will get it as half. I will keep that as it is. I have not repeated. You should do all those calculations. What? Put sin theta is equal to x, cos theta d theta equals to dx. So change the limits. Limits are from, earlier it is 0 to pi by 2. Now the limits are between 0 to x. So follow all the procedure. Please write down the steps. I have not done it. You have to do it. So I will get the integration value as 1 by 2, but 2 times. So 1, 2 gets cancelled. You will be left with only 2 pi um. This is your equation 1. What is equation 2? Step 2. For isotropic antenna, W is equal to 4 pi u naught. So take the ratio of equation 1 and 2. You will get W by W is equal to 2 pi u naught divided by 4 pi, 2 pi um by 4 pi u naught. So pi cancels, 2 ones are, 2 twos are. So it is 1 is equal to 1 by 2 um by u naught. Okay. So what is um by u naught? Um by u naught is directivity d. So 1 is equal to d by 2. So what is D? D equals to 2. So we got the directivity 2, which is more than 1. Okay, practical antennas, you will get the directivity more than 1. Ideally, you should get 1. Now, there is, based on these two results, we can observe something. The directivity of unidirectional cosine, we got it as 4. Directivity of bidirectional, we got it as 2. So it has got reduced by half, right? So agar unidirectional cosine pattern hai, you got 4. For bidirectional, you get 2. So unidirectional means more focused. Okay, it is just like your battery torch. If it is unidirectional, directivity is more. Suppose you're keeping some hand here, okay, on the mouth of the battery torch. Only some area, if you just keep it open, you're more, it looks like more radiation, more focused beam you will get. But if your battery torch mouth is bit wider, see, wider, the no doubt the radiation spreads, it will cover more area, more area can be seen. However, not more, not larger distances. No doubt it will cover, it will spread around, its surroundings, but it will not cover much distance. Directivity will become less. So unidirectional, more value. Bidirectional, you will get lesser value but more area coverage. So bidirectional will be half of the unidirectional. This is one observation you can make. Similarly, let's go for next question. Unidirectional sine power pattern. We also call this donut pattern. Sine pattern is called donut pattern. So again, try solving this. We will start with the given equation. U is equal to um. This time it is a sine theta. Earlier it was cos theta. And one more data is given to you. Unidirectional theta range is pi by 2. Phi range is 0 to 2 pi. We know that first step, go for total radiated power calculation. W is equal to double integration u d omega, and substitute u as um sine theta, d omega is sine theta d theta, and for phi it is d phi. So outer integration represents phi, inner integration represents theta. Apply the limits. I have kept it outside. It is a constant term. Throughout it will be outside. Integration of unidirectional. This is 0 to 2 pi range for phi. Inside it will become 0 to pi by 2. Unidirectional pattern. And sine theta into sine theta, you will get sine square theta d theta. I will make use of this trigonometric function sine square theta, which is equal to 1 minus cos 2 theta by 2. This trigonometric function, I will substitute it here. 1 minus cos 2 theta by 2. So what I have done here, I have calculated this integration directly. What is the integration of 0 to 2 pi into d phi? D phi, this is nothing but 1 into d phi. What is the integration of a constant? It is x. So it is, here the variable is phi. So it is, for d phi it is phi. Limits are 0 to 2 pi. If you substitute upper limit first, you will get 2 pi minus 0. So you will get 2 pi. I have done that directly. I have put the value. Then go for integration of this. So what I will do here, I will cancel this 2 for my ease. Okay. So you will be left with um into pi, and remaining are, I will just apply this integration to both 1 and cos 2 theta. So if I split this, this will be integration of 1 into d theta, minus integration of cos 2 theta into d theta. Okay, splitting the integration. Then apply the integration. Integration of d theta is theta. Okay, theta. The range is 0 to pi by 2. So substitute the limits. Upper limit is pi by 2 minus lower limit is 0. So you'll get pi by 2. So I have done that, pi by 2 here, minus Now, what is the integration of cos? It is some minus sign. No, I think sine 2 theta. Integration of cos 2 theta is sine 2 theta divided by 2, because this 2 is also there here. So divided by 2, the range is between 0 to pi by 2. So apply this, apply the upper limit first. It will become sine of 2 into theta is pi by 2. So 2 cancels and whole divided by 2. So if this will be sine of pi whole divided by 2. So what is sine pi? It is 0. So anyhow, if you apply this and apply the lower limit also, apply the lower limit minus sine of 2 into theta. Theta is 0. 2 into 0. So divided by 2. So anyhow, this value became 0. This value also becomes 0. Sine of pi is 0. Sine 0 is 0. So anyhow, this total second integration will eliminate. We won't get it. It becomes 0. So if you do that, I have substituted it. So simplify this. You will get pi square by 2 as the equation 1. What is the equation 2? Equation 2 is, we know that for an isotropic antenna, W is equal to 4 pi into U naught. Then third step is taking the ratio of 1 and 2. So equation 1 and equation 2. So W by W is equal to pi square UM by 2 divided by 4 pi U naught. Solve it. This will become 1. Then 1 pi will go. Then don't cancel this 2 and 4, because both are in the denominator. They'll become 4 into 2, which is equal to 8. Remaining are um and 1 pi will remain, um into pi divided by u naught. Now, what is um by u naught? Um by u naught is directivity D, which is equal to, take 8 here, take pi to the denominator. So 8 by pi is equal to D. What is 8 by pi? You use your calculator, you will get 2.546. This is unidirectional sine power pattern, donut pattern. Similarly, we can try calculating bidirectional sine power pattern. For bidirectional sine pattern, again, most of, all of the steps will remain the same. Only the theta range will change from uni to bi. So the range is now pi. Earlier it was pi by 2. So even in solution also repeat all the steps. See here, I have taken equation. I have substituted um into sine theta d theta d phi. It will become sine square. Sine square is 1 minus cos 2 theta by 2, right? Everything is same, but check here, it is 0 to pi. So what I can do, I will go for integration property again. If it is say 0 to pi range, I can write this as 2 times 0 to pi by 2. I will go for that application, 2 times 0 to pi by 2 and sine square theta d theta. If I solve this earlier, what I got, integration of 0 to pi by 2, I have got only pi by 2. Second term was 0, so I got only pi by 2. Here also I will do the same. Everything is same. This 2 times, application of the integration form property, 2 times pi by 2, 2 I will keep it as it is. And you will get this, you can solve it, 0 to pi by 2, you try solving it. So you will get pi square into um. Earlier we got it as pi square um by 2. One extra 2 term will cancel. With what? With one denominator cancel with this numerator 2. So you will get pi square into um. You try solving this. You can even please you can expand this. Sine square is 1 minus cos 2 theta. Apply the limits, you will get. Okay. So you will get this pi square um. Then second equation, W is equal to 4 pi into u naught. Then what is the third step? We should go for division, 1 by 2. So taking the ratio, 1 is equal to pi square into um divided by 4 pi u naught. So one pi will get cancelled with the denominator. You will get pi by 4 um by u naught. What is um by u naught? It is directivity. D is equal to, take this 4 here, take pi denominator. So 4 by pi. Directivity is 1.27. Again, you can observe here, if you observe the unidirectional, you got 2.54. If you observe bidirectional, you got half of it, 1.27. 1.27 into 2, you calculate, you'll get 5 point. Okay. So again, unidirectional, bidirectional, the values, comparative values of directivity, if you observe, unidirectional is more, bidirectional directivity is half of the unidirectional. Okay. Let's take the fifth problem. It is sine squared power pattern. I have solved it for bidirectional. You can solve for unidirectional also. Sine squared. So squared means what? U equals to um sine square theta. Earlier we have seen cos theta and sine theta. Now it is sine squared. Sine square theta is the power pattern. I have not written here bidirectional, right? So this should be filled with pi. You can try it for unidirectional. Okay, start with the first step. W is equal to double integration of u into d omega. Outer integration is phi, inner integration is theta. U I have substituted, um sine square theta, d omega is sine theta d theta, and this outer integration, it is d phi. Now, separate out the terms. Um is a constant term, keep it out. For this first integration, only one term is there, so apply that, d phi. For second integration, it is already I have covered. It is sine cube theta d theta. Okay. Now, there are two ways you can solve this. One way is, see, solving of this is simple. Integration of d phi is phi. Apply the limits, you will get 2 pi, 2 pi into um. But solving of this integration sine cube, there are two methods. Either you can use one identity of the integration, which you can see it on the screen. I have written this identity, 0 to pi by 2 sine raised to n x dx. If this is the thing, and n should be odd, that is the condition. Here it is odd, 3. That time you can apply this formula, n minus 1, n minus 3. This is a general formula I have written for n. You can substitute whatever n you have. N is 3. So accordingly you can substitute 3 minus 1. 3 minus 3, 0. So don't consider, only consider first value divided by 3 into 3 minus 2 is 1 into 3 minus 4 is minus 1. Negative term you will get, remove it. So only take first term in the numerator, two terms in the denominator. So this is the equation you can use. This is, I think this you have solved it, you have derived it in your mathematics. Sine raised to n when n is odd, this is the formula. If you see, integration is 0 to pi. So what I can do, use the property of integration, make it 2 times pi by 2 first. Once you do this, 2, keep it as it is, multiplied by, use this formula, 0 to pi by 2 sine cube. I have written it here, sine cube, you will get 2 by 3. So substitute that, 2 by 3. So I have done that. This is as it is. Then integration of d phi is what? You will get 2 pi. Then 0 to pi limit is there. I will make it 2 times 0 to pi by 2, and this integration using this formula you will get 2 by 3. Substitute 2 by 3 and this 2 is as it is. So it will be 2 into 2 into 2, 8 pi by 3, equation 1. I told you there are two ways you can solve this. One is using this. One more way is split this power. A bit elaborative procedure, but you can try this also. Sine square theta into sine theta. You can do this also. Sine square is also 1 minus cos. You know, it is bit lengthier. Instead of going for that, you better go for this formula. This is the formula from the integration. You might have derived this already in mathematics. So using this formula, you can directly use it. You can calculate, you will get equation 1. What is equation 2? W is equal to 4 pi into u naught. Third step is taking the ratio of equation 1 and 2. Equation 1 and 2, W by W, 1 is equal to 8 um pi by 3 divided by 4 pi u naught. See, pi cancels, then um by u naught is there. 8, I think 4 3s are 12. Both are denominators. This will be denominator 12 and numerator is 8. So 8 by 12 I have written it. And again 4 2s are 4 3s are. You will get 2 by 3 um by u naught. Okay. After that, if you check, um by u naught is directivity D. So D is equal to, take T to this side, 3 to this side numerator, 2 to the denominator. It will be 3 by 2, which is 1.5. Okay. So this is for bidirectional sine square pattern. Now, if I ask you, what is unidirectional sine square? There is a relationship I told you, unidirectional and bidirectional. अगर आपका bidirectional value 2 है, unidirectional double रहेगा. Unidirectional ज़्यादा रहेगा, bidirectional कम रहेगा. We have now calculated for bidirectional. It is 1.5. So tell me, for unidirectional what it will be? It will be double the value, which is 3. Or bidirectional will be half of the unidirectional. 1.5 into 2, you will get 3. You can calculate this manually. You can solve the problem. You will get answer as 3. Let's take the next problem. It is cosine squared power pattern. Here the problem which we solved is sine squared. Sine squared, I think bidirectional we calculated, and a similar concept we extended to unidirectional, and both directivities are related in this way, 1.5 and 3. One is double the other. Okay. Now we'll go for cosine. So given pattern is u equals to um cos square theta. Okay. Here I have calculated for unidirectional, or similarly we can go for bidirectional. Check it. Cosine squared power pattern. So u is equal to um cos square theta. Unidirectional, so theta range is 0 to pi by 2. Phi range is 0 to 2 pi. So take the equation, first step, find the total radiated power W, which is equal to double integration of u into d omega. It is looking a bit blurred. Apply the values. U is um cos square theta, d omega is sin theta d theta, and for phi it is d phi. Okay. Now I have clubbed all the phi terms at one and theta terms at the other. And the first integration value is 2 pi. Second, again here you can go for different methods for calculation of this integration. I have used substitution method. What I can do? Substitute cos theta equals to x. Then sin theta, what is the differentiation of cos? You will get minus sin theta. So minus sin theta d theta equals to dx. So as theta range is 0 to pi by 2, when you are substituting it as x, even your limits will change. So check, if you put theta equals to 0, see cos 0. What is cos 0? It is 1. So if theta is 0, x value is equal to 1. And if theta is pi by 2, cos of pi by 2, what is x equals to? X equal to cos pi by 2, which is 0. So range is now reversed. See, it is 1 to 0. Okay, lower limit is 1, upper limit is 0. The limits have changed. Be careful here while writing. Don't write like this, 0 to 1. It is first value is 1, second value is 0. So lower limit is 1, upper limit is 0. And substitute, what is cos theta? Cos theta is x. So it is cos square, so x square. And what is sine theta d theta? Sine theta d theta is here negative sign, so minus dx. So it is minus dx. So this will be 2 pi um as it is minus, what is integration of x square? It is x cube by 3, and apply the limit. Lower limit is 1, upper limit is 0. Apply the limits. Minus, if you apply 0, it will become 0 by 3, minus, apply this lower limit 1, 1 cube by 3, which is 1 by 3 only. So if you just take this, you will get minus 1 by 3, minus 1 by 3, and this negative into negative, it will become positive. So 2 pi um by 3. This is the step 1. Total radiated power of an antenna is 2 pi um by 3. Go for the second step. For an isotropic antenna, W is 4 pi into U naught. So then third step is taking the ratio of 1 and 2. So W by W is equal to 2 pi um by 3 divided by 4 pi U naught. Taking the ratio, this is 1 is equal to, I think pi's will cancel, 2 ones are, 2 twos are, and here it is denominator 3, denominator 2, 2 threes are 6. So 1 by 6 into um by u naught, um by u naught. So what is um by u naught? It is d. So d by 6, 1 is equal to d by 6. So take 6 to the other side, you will get d equals to 6. This is the directivity of cos squared power pattern. We have calculated it for unidirectional. Now, according to the relation for unidirectional and bidirectional, if unidirectional you got it as 6, right? Just now we have got d equals to 6. Bidirectional will be half of this. So I have written the answer here, d is 3. You can go manually, you can solve this the same way how we solved it for unidirectional. What will be the change in between both? Here instead of pi by 2, you will get 0 to pi. So you would use the integration property, make it 2 times 0 to pi by 2. So whatever answer you get, here one extra 2 term will come. After that, when you go for this, you will get this as 3. Okay, that is the change. You please try solving it by yourself. I have solved it for unidirectional. You try solving it for bidirectional. Then take one more problem. Unidirectional pattern, u equals to um cos cube theta. Okay, this is the question. Actually, the question is only this much, u equals to um cos cube theta. I have done it for unidirectional. You can even solve for bidirectional as well. Given u equals to um cos cube theta, and unidirectional theta range is only 90 degrees, 0 to pi by 2, phi is 0 to 2 pi. Go for the first step. W is double integration u into d omega. Substitute u, it is um cos cube. D omega is sine theta d theta, and for this integration, outside integration, it is d phi. Then what I have done, I have taken it outside. This integration I have clubbed it with phi and 0 to 2 pi. And this inner integration theta, it is unidirectional, cos cube theta sine theta d theta, cos cube theta sine theta d theta. This is into, apply the integration, it will be phi, apply the limits, it will be 2 pi minus 0. So 2 pi Now solving this integration, again I have used this substitution method. If I just look at this, cos cube theta, So cos theta, substitute cos theta is equal to x. If I substitute that, minus sin theta d theta will be cos of integral differentiation of cos is minus sin theta d theta equals to dx. Now change the limits. It is actually 0 to pi by 2. So apply both 0 and pi by 2. Check. If I apply 0, what is cos 0? Cos 0 is 1. So I will get x equal to 1. And put theta is equal to pi by 2. Cos pi by 2 is 0. So x equal to 0. Again the limits are changed. Lower limit is 0 and pi by 2. Here the lower limit will be 1 and upper limit is 0. It is not 0 to 1. It is reverse, 1 to 0. And cos theta is x. So I have substituted x. It is cube, x cube. Sin theta d theta. Sin theta d theta is this negative sign. So minus dx. Negative dx minus of what is the integration of x cube. X cube is x raised to 4 by 4. And apply the limits. If you apply the limits, it will be minus of 0 by 4 minus 1 by 4. So it is something like this, minus of minus 1 by 4, right? Minus of minus 1 by 4, which is plus 1 by 4. And 2 1s are 2 2s are, you will get pi um by 2. Now this is equation 1. Equation 2 is w equals to 4 pi u naught. So take the ratio of equation 1 and 2. W by w is 1, which is now pi um by 2 divided by 4 pi u naught. Pi cancels. This denominator 2 and this denominator 4 gets multiplied. It is 8. Um by u naught is directivity d. So it is 1 is equal to d by 8. So what is directivity? It is 8. If I ask, I have calculated unidirectional. If I ask bidirectional, here I have got 8. So for bidirectional, you will get 4. Half of the unidirectional. The next question, it is a question paper problem. U equals to um sine theta into sine square phi. And theta ranges they have already given, phi ranges also they have given, both are 0 to pi. So this is a question paper problem. If you just check out, both ranges of theta and phi are given to you as 0 to pi. So let's start solving the problem. First step is we need to find the total radiated power of an antenna W, double integration U d omega. So outer integration is for phi, the inner integration is for theta. U is given sine theta sine square phi. And d omega is, I have written here, the sequence is changed, sine theta into d theta. And for outer integration, it is d phi. Now I will club all variables at one side, which are same. Is constant, taken out. Both ranges are 0 to pi. Outside, this is for phi. Check out, for phi, it is a sine square. Two terms are there. So I have written sine square phi into d phi. Then for theta, it is sine theta, d theta. It is sine square. So I have clubbed all phi terms at one side, then all theta terms at one side. Now, if you check, both are for 0 to pi and both are sine square. So if I calculate one, the other will be same. What I can do, as it is, instead of sine square, I can use 1 minus cos 2 theta by 2. Here also 1 minus cos 2 phi by 2. One is for theta, one is for phi. And these denominators 2 and 2, I have taken it outside, by 4. So what I can do, apply this, it is 0 to pi d theta, first term, minus integration of cos 2 theta d theta. Similarly, here also integration of, this is 1 into d phi, one term, minus integration of cos 2 phi d phi, second term. This is outside as it is. Apply the integration. Integration of d theta is theta, range 0 to pi. Integration of cos is sine, sine 2 theta and 0 to 2 pi, sorry, 0 to pi. Both ranges are 0 to pi. And similarly here also apply the integration. It is phi and it is sine. Both are same. Okay. See, only variable has changed. Otherwise, both brackets are same. Then this is by 4 as it is. Apply the limit. It will be pi minus 0, which is pi, minus it is not only this much. Okay, this complete bracket indicates this bracket. Let's see how it is. If you just take this, it is something like this: pi minus 0 minus, what is sine of pi? Sine of pi, pi 2 pi 3 pi, it is 0 only. So this will become 0 only. So I have written it only pi minus 0. Same thing, even if you apply here, you will get pi minus 0 only. So what is the total value? You will get pi square by 4. Pi square by 4. W is equal to, this is first equation. Equation 1. Equation 2 is, for an isotropic antenna, it is W is equal to 4 pi into U naught. So take the ratio of equation 1 and 2. W by W is pi square by 4 divided by 4 pi U naught. So 1 is equal to 1 pi gets cancelled. Don't cancel 4 and 4. Both are denominator terms. It will become 4 into 4, 16, not 4 by 4. 1 pi will remain in the numerator. Pi by u naught. By u naught. So what is by u naught? It is d. So how it looks like? 1 is equal to pi by 16 into d. So what is d? D equals to, take 16 to the other side, pi to the denominator. It will be 16 by pi. You will get 5.092. This is the question paper problem. You will get the directivity like this. There is one more question paper problem. You can see it here. U equals to sine square theta into sine cube phi. Both theta and phi terms are there. And ranges are given 0 to pi by 2, 0 to 2 pi. They have mentioned this very specifically, both the ranges. Okay. Start solving. First is step 1, finding the total power. W, outer integration is phi, inner integration is theta. U is sine square theta sine cube phi. D omega is sine theta d phi. This outer integration is d phi. Okay. I have taken it outside. It is a constant. Now keep all theta terms at one place, phi terms at one place. So if you check phi, range is 0 to 2 pi. Observe it. Phi is 0 to 2 pi, theta is 0 to pi by 2. So 0 to 2 pi. Phi terms are sine cube phi and d phi. So I have written it. Then for theta are sine square, d theta and sine. So total is sine cube. Sine square into sine is sine cube. So sine cube theta into d theta. So both are cube terms, just like the previous problem. Once you solve this, the same is the answer with the theta also. Only variable has changed. Both are for sine cube only integration. So again, I'll use the identity in integration. But identity is for the range 0 to pi by 2. But here you can check it. One is for 0 to 2 pi, one is for pi by 2. For this, you can directly apply this. But however, for this, you need to do certain modifications. 0 to 2 pi means how many times 90? Pi by 2 into 4. So integration of 0 to 2 pi, how can you write this? You can write this 4 times 0 to pi by 2. So you have to apply this integration property. And both are odd terms. N power is odd. So apply this formula, you will get 2 by 3. What we can do? Is as it is. 0 to 2 pi is 4 times 0 to pi by 2. 4 times 0 to pi by 2. and a sine cube value is 2 by 3. I have written this here, 2 by 3. For this second, it is 2 by 3. Simplify it. You will get 4 um, 4 into 2 into 2. You will get 16 by 9 um. And what is equation 2? It is 4 pi u naught. So if you just take the ratio of these two, w by w is equal to, taking the ratio. So if you take the ratio of equation 1 and 2, it is 16 by 9 um in the numerator. W by w is equal to divided by 4 pi u naught. So 1 is equal to, see what all I have done, 4 ones are, 4 fours are, 4 in the numerator um divided by 9 pi u naught, 9 pi u naught. So if you solve this, you will get directivity as 7.02. Okay, this is the directivity for the given question. They have not given you anything unidirectional or bidirectional. Directly they have given you the theta and phi range. Now one important derivation you have here, based on all these power patterns, we have solved it for sine theta, cos theta, sine square, cos square, and 2 question paper problems. Based on all these, this one general question you have as a derivation, what the question says, show that the directivity for unidirectional operation, unidirectional means theta range is between 0 to pi by 2. It is 2 times n plus 1 for an intensity variation of u equals to um cos raised to n. So here the variation they have given you as um cos raised to, okay, this is the equation, u equals to um cos raised to n theta. So let's start solving this. For that, given u equals to um cos raised to n theta, and it is unidirectional given to you. So ranges are 0 to pi by 2 and phi are 0 to 2 pi. So let's start solving. We need to follow the 3 steps. Even for the derivation also, let us start following the same steps what we followed for the problems. So w is equal to double integration of u into d omega. Outer range is for phi, inner integration is for theta, u is um cos raised to n theta. What's the difference between all these problems which I have solved and this problem? It is only the power n. N is a general term used. Here in the problems which we have solved just now, they are all 1, 2, 3 like that powers. Here it is n. That's the difference. D omega is sine theta, d theta, and the integration, it is d phi. Okay, now let's start solving. Again we will go for the same. What we will do, we will go for substitution method for solving the integration. It will be cos theta. Substitute cos theta is equal to n. Again we will go for the substitution method. Substitute cos theta is equal to x. So if I do that, the differentiation of cos is minus sine. So minus sine theta into d theta equals to dx. The limits will also change. For theta it was 0 to pi by 2. Now for x, let's see, because we have substituted theta as x, so even limits will change. So if I take theta as lower limit 0, if 0, what is cos 0? Cos 0 is equal to 1. So theta, if it is 0, x will change to 1 because this 1 is equal to x, right? And upper limit pi by 2. What is cos pi by 2? Cos pi by 2 is 0. So x value is 0. Cos pi by 2 is 0, x equals to 0. So the limit is not now 0 to pi by 2. It is 1 to 0. Lower limit 1, upper limit 0. Now substitute cos theta is x. I have written that x, power is n. And what is sine theta d theta? It is minus dx. So it is minus dx. I have written that. Then this I have already explained you. Integration of d phi is phi, and apply the limits between 0 to 2 pi. So apply the limits, 2 pi minus 0, you will get 2 pi only. So that I have directly written here. I have not solved it. and integration. What is integration of x raised to n? It is x raised to n plus 1 by n plus 1. This is the integration application, and apply the limits. Negative sign I have kept it as it is. Now check it, this negative as it is. If I apply 0, what will happen? It is something like this, minus of 0 by something is 0 only, minus apply this, it will be 1 by, yeah, because 1 raised to anything is 1, plus 1. Okay, so 0 will go, it is something like this, minus of minus n plus 1. So minus into minus is plus. So that's what it is, minus of minus, it will become plus 2 pi um by n plus 1. This is equation 1. What is equation 2? For any for an isotropic antenna, W is equal to 4 pi u naught. So take the ratio of equation 1 and 2. W by W is equal to 2 pi um by n plus 1, 2 pi um by n plus 1 whole divided by 4 pi u naught. Now this is 1 is equal to um by u naught, by u naught. I think 5 will cancel, 2 ones are 2 twos are. So this 2 is in the denominator, I have written numerator no terms, and denominator you have n plus 1. So this is equal to D. How the equation is? It is actually 1 is equal to 1 by 2 of n plus 1 into D, or D is equal to, take this to the other side, you will get D equals to 2 times n plus 1. So check the prove that question. What we need to prove? It should be 2 times n plus 1. Whether we got this? Yes, we got it as 2 times n plus 1 directivity. So these are all the problems which I have solved based on the power patterns. Okay. In the next session, we will be going to see about the field patterns. Basically, in patterns, we have two types. One is power pattern, one is field pattern. Power patterns, just now we have seen, it is the graph which shows the variation of radiation intensity, U, right? We have solved the problems based on this, wherein U was the major part, and directivity, how we calculated, it was the ratio of um by u naught. So radiation intensity is the major parameter here, and the variation is with respect to SR, that is only radial component of the Poynting vector we have considered. So in the next session we will see about the field patterns, wherein remaining two, the Poynting vector components S theta and S phi we will consider, not the radial component.